Today's video is on integration using residues. In today's video, we are going to find the poles of the function z plus 1 by z square into z minus 2 and the residues at these poles. See, first of all, what is the function value given? The function value is given as f of z is equal to, this is z plus 1 by z square into, this is z minus 2. First of all, we have to find the poles of the given function. In order to find the poles of the given function, we have to equate the denominator to 0. That is, z square into z minus 2 is equal to 0. After equating the denominator to 0, see here, if I equate z square to 0, then z is equal to 0 is a pole of order 2. Is a pole of order 2. And next one, if I equate z minus 2 to 0 and z value is equal to 2, which is a simple pole. So this is a simple pole. See, z is equal to 0 is a pole of order 2 and z is equal to 2 is a simple pole. So we got the pole values of the given function. And next we have to find the residues at these poles. At these poles we have to find the residue value. In order to find the residue value, see, let me explain you. There is a formula. So residue of f of z at point z is equal to z naught is equal to, this is 1 by m minus 1 factorial into limit z tends to z naught d by dz times of m minus 1 into, this is z minus z naught per n into f of z. See, in order to find the residues of order 2 or 3, m value is the order value. So we have to substitute the m value as, so m is the order value, here m order value is equal to 2 and z naught is the pole value which is equal to 0. And now if I substitute the same thing here, then this will be residue of f of z at point z is equal to 0 is nothing but 1 by m is equal to 2, that is 2 minus 1 factorial into, this is limit z tends to z naught is 0, this is d by dz times of m minus 1, this is 2 minus 1 into, this is z minus z naught value is 0 and m value is 2 and f of z. So what is our f of z value? See, I am showing here, that is z plus 1 by, so this is z plus 1 by, this is z square into z minus 2. Clear? And now after writing f of z value, so here 1 by 2 minus 1, 2 minus 1 is 1 and again it is 1, so I'm leaving that one. So this is limit z tends to 0, this is d by dz times of, so power 1 into, this is z square into, this is z plus 1 by z square into, this is z minus 2. Now I can cancel this one. So after that one, I have to make a derivative for one time, that is d by dz times of. So in order to make a derivative, so this is of the form u by v. So this is u by v. So in order to make the derivative for this function, so I am writing this one, that is d by dz times of limit z tends to 0, that is d by dz times of, the rest of the function is this one, that is z plus 1 by z minus 2. So if I want to make a derivative, that is, which is in the form u by v rule, so this will be, the derivative value will be v square v u dash minus u v dash. So we have to square the v and again we have to leave v for one time, you have to make a derivative for u and we have to leave u and make a derivative for v. So that's what I'll do here, and later I'll keep z value as 0, that is limit z tends to 0. So this is v square, that is z minus 2 whole square. So this is z minus 2 and u derivative here is 1 minus u value is z plus 1 and here v value, v derivative is 1, and therefore in this if I keep the z value as 0, this will be 2 minus 0 minus, this is 0 plus 1 by, this is 0 minus 2 square. So this value will be minus 2 minus 1 by 4. So the value here is minus 3 by 4. Therefore the residue, see here I am showing the residue of f of z at point z is equal to, at the pole value z is equal to 0 is nothing but minus 3 by 4. So this is the value, residue value at the pole z is equal to 0. Clear? And next one, the next pole value is z is equal to 2. So for z is equal to 2, as it is a simple pole, so for z is equal to 2, as it is a simple pole, so the residue value here is residue of f of z at z is equal to z naught. Value here is limit z tends to z naught. This is z minus z naught into f of z. So if I substitute here as a z naught value as 2, here z naught value is equal to 2. So if I substitute, then the residue of f of z at z is equal to 2 value is equal to limit z tends to 2. This is z minus 2 into f of z. So what is our f of z value? F of z value is this one, as z plus 1 by this is z square into this is z minus 2. So if I cancel z minus 2 and keep 2 in the z value, so this will be 2 plus 1 by this is 2 square. So which is equal to 3 by 4. So this is the residue value of f of z at point z is equal to 2. So this is how we have to find out using the formulae. So this is the residue value at the pole z is equal to 2. The value here is 3 by 4. And see, let me explain you once again. So here what is given? So we have to find the poles of the given function. F of z is equal to z plus 1 by z square into z minus 2 and find the residues at these poles. So here the function is this one, and in order to find the poles of the given function, we have to equate the denominator to 0. So if I equate z square to 0, so z is equal to 0 is a pole of order 2, and if I equate z minus 2 to 0, so this is z is equal to 2, which is a simple pole. So at point z is equal to 0, so this is the formula. In this formula, if I keep the order value is equal to 2 and z value, the pole value is equal to 0 in this, and we have the function value f of z here, and after cancelling z square, so we have to make a derivative for one time and we have to substitute z value as 0, so that we'll be getting the residue value of the given function at the pole z is equal to 0, so which is minus 3 by 4. And the next pole here is z is equal to 2. So for z is equal to 2, as it is a simple pole, the formula is also so simple, limit z tends to z naught, z minus z naught into f of z. So here z minus 2 into f of z value is ready here. We have to cancel z minus 2, and in the remaining function we have to keep z value as 2, and this will be our pole value. This will be our residue value at the corresponding pole z is equal to 2. So this is how we have to solve. Thank you so much for watching. If you really like this video, please practice and go through this video for once again, and please pass it on to your friends and subscribe to this channel. Thank you so much.